Welcome to The Explainer, everyone. Today, we're diving into a story of absolute, unprecedented transformation. We're looking at how an entire country evolved from having mostly raw dirt roads to constructing just mind-bending megastructures, and doing the whole thing in exactly 30 years. We're exploring a timeline of engineering execution that is honestly hard to even wrap your head around. It's an explainer of pure, unadulterated scale. So, let's get into it.
Here's our roadmap for today. We'll start with the beginning of miracles, move right through impossible engineering, see how these projects are literally changing Earth's rotation, explore smart cities of the future, venture into space and mysteries, and wrap it all up with the speed of tomorrow. It's a wild journey, from conquering gravity to altering physics, all the way to AI-run cities and deep space signals.
Okay, Section 1. The beginning of miracles, going from mud roads to megastructures. We really need to set a baseline here that puts this undeniable speed of execution into the proper perspective.
The contrast here is just jaw-dropping. Think about it. Just 30 years ago, this landscape was defined by raw mud roads. Fast forward to today, and that exact same geography is completely dominated by cloud-piercing bridges, massive telescopes listening to deep space, and cities entirely driven by artificial intelligence. 30 years is often the amount of time other nations take just to plan and approve infrastructure on this scale. The sheer velocity of this leap from the past to the future is what we're unpacking today.
Moving on to Section 2, Impossible Engineering, Defying Geography. Let's see exactly how engineers fought back against extreme physical landscapes using pure mathematics and, well, thousands of tons of heavy steel.
I want you to consider the number 20. That is the number of stories making up the Panlong interchange in the mountainous city of Chongqing. Just imagine this, a massive 20-story tall structure with 8 distinct highways stacked right on top of each other. It looks almost like a giant plate of noodles dropped from the sky. But it's perfectly calculated. This interchange precisely routes over 100,000 cars a single day in 6 different directions, perfectly carved into a totally unforgiving mountain landscape.
And then you have the SiDu River Bridge, faced with an impassable 900-meter gorge, which, by the way, is deeper than the Empire State Building is tall. Standard construction was just completely impossible. So what do? They used rockets. Yes, literally, they fired rockets to shoot the initial thin guide wire all the way across the abyss. Once that wire was across, they used it to pull the massive, heavy steel cables over, eventually allowing workers to build the bridge on platforms that often sat completely above the cloud line. Unbelievable, right? Now, all this engineering actually actively compresses time. Because of those rockets, what used to be a grueling, genuinely dangerous 3-hour trek through the mountains has been reduced to a smooth 90-second drive across the SiDu River Bridge. 90 seconds! Similarly, the Hong Kong-Zhuhai-Macau Bridge took a massive 4-hour journey and completely slashed it down to just 30 minutes. This isn't just about building big things, it's about changing the fundamental way people connect with each other. And that Hong Kong-Zhuhai-Macau Bridge? It takes this ambition even further. It's 55 kilometers long, cost $18 billion, and uses enough steel to build 60 Eiffel Towers. But honestly, the most incredible part? To avoid blocking massive cargo ships in a super busy shipping lane, engineers didn't just build the bridge higher. They did the unthinkable. They built 2 artificial islands right in the middle of the open ocean and plunged the highway straight down into a 6.7-kilometer underwater tunnel between them. All right, Section 3, Changing Earth's Rotation, Harnessing Nature's Power. This is where we shift from building over nature to literally bending planetary physics. Okay, I really want you to focus on this next number, 0.06 microseconds. That is not a typo. The Gorges Dam is so unbelievably massive that it holds back 42 cubic kilometers of water in one centralized location. And the shift of that much water weight onto one specific point on the globe has actually officially slowed the Earth's rotation. Because of this single piece of infrastructure, our days are now 0.06 microseconds longer. It's just wild. So how does this happen? Well, it's due to a physics principle called the moment of inertia. Basically, it explains that when mass shifts further from the center of a rotating object, its rotational speed slows down. It is exactly like a spinning ice skater extending their arms outward to slow down their spin. NASA scientists actually calculated this exact phenomenon with the dam. And by the way, while it's out there slowing the Earth, it's also generating a staggering 88.2 terawatt-hours of electricity a year. It perfectly showcases how a human-made structure can both alter planetary physics and power an entire nation. Geography is also being harnessed for immense energy in other ways. Take the Datong Solar Farm in Shanxi. It's a staggering 250 square kilometers, so large it's clearly visible from space. But what's really fascinating here is its design. It was ingeniously shaped like the Great Wall of China, and that's not just for aesthetics. That specific pattern perfectly aligns the solar panels with the natural mountain slopes, maximizing sunlight absorption from every possible angle. It currently powers 1 million homes all on its own.
Let's jump to Section 4, Smart Cities of the Future, where AI replaces waiting. What does everyday life actually look like when intelligent algorithms run the grid?
Well, in Beijing's Zhongguancun district, the city literally thinks for itself. Traffic lights? They don't rely on timers or rigid schedules anymore. Instead, an overarching AI reads the live traffic flow every single second, constantly adjusting the red and green lights on the fly. If an accident happens, the system doesn't wait for a human in a control room. It automatically and instantly diverts traffic around the crash. Because of this, overall traffic jams have been reduced by 40%. Oh, and since 2024, fully autonomous self-driving taxis have been operating commercially on these very streets.
Now imagine traveling to Hangzhou, famously known as the Face City. You don't need a wallet, you don't need a phone. Your face replaces everything. It is your cash, your ATM card, your token for the bus and the metro, your library pass, and even your hotel check-in. The city's entire infrastructure relies on a highly secure facial recognition system, a form of identity you can never lose, drop, or have stolen.
And the sheer scale of this is just staggering. By 2024, over 2 million daily transactions in Hangzhou were happening entirely through facial recognition scanning. 2 million times a day, someone just looked at a screen and went about their business, entirely frictionless.
Up next is Section 5, Space and Mysteries, the Eerie Unknown. We're trading these bustling AI cities for vast, eerie isolation and the profound mysteries of the universe.
Where did a perfectly repeating signal from 3 billion light-years away come from? This is the chilling reality scientists have been facing since 2020. After powering up their colossal new deep space technology, they picked up this pattern, a signal from the unimaginable depths of the cosmos. And to this day, no one knows who or what sent it. To listen for that specific signal, they built the Fast Radio Telescope in Guizhou. This absolute behemoth is 500 meters wide. You could comfortably fit 30 full-size football fields inside its dish. But to ensure it could hear whispers from 3 billion light-years away, they needed total, absolute electronic silence. So they completely relocated 9,000 residents from the area to enforce a strict 5-kilometer zero electronics zone. No Wi-Fi, no cell phones, no cars. Just the largest ear on Earth, pointed directly at the stars.
But back down on Earth, there is another, deeply fascinating mystery. What happens when you build a perfect city for 1 million people, and nobody comes?
Welcome to the totally surreal reality of Ordos in Inner Mongolia. Here, you have flawless infrastructure, finished by 2010. Perfect streets, fully operational hospitals, schools, and massive shopping malls, where the street lights and elevator lights turn on every single night. But on the flip side, the population data shows the city is 90% empty. It is known globally as the world's largest ghost city, harboring only around 100,000 residents out of a planned 1 million. It's an impeccably maintained, fully functional metropolis, just patiently waiting in silence for citizens who never arrived. And that brings us to our final section, Section 6, The Speed of Tomorrow, Building from Scratch. We are going to look at what happens when virtually endless resources meet a total lack of historical baggage. What actually happens when you start with a completely blank slate. Let's take Zhang'an New City as an example. In April of 2017, this area was nothing but empty fields and dirt. But because they didn't have historical baggage to worry about, like replacing old pipes or routing around ancient neighborhoods, they built the underground roads and the entire AI network infrastructure first. By 2024, just 7 years later, a fully modern 2,000 square kilometer AI city was completed. And because all the traffic is buried underground, the surface is a perfectly noise-free pedestrian utopia. 7 years, from dirt to the future. This brings us to a really unavoidable thought. As an explainer of this source material, we remain strictly neutral on the politics. You can entirely agree or disagree with the policies behind these megaprojects. But looking purely at this factual, undeniable speed of engineering execution, the sheer velocity of building bridges with rockets, cities with AI, and dams that literally alter the spin of the globe, we are left with this provocative question. If this is what happens when you go from mud roads to AI metropolises in 30 years, How much further can humanity push the boundaries of physics and engineering in the next 3 decades? Thank you for exploring this fascinating timeline with me. Keep wondering and keep learning.